So we start. Don't forget to fill up the attendance form and participant evaluation form after this course. I'm Aaron Anwar from Department of Chemical Engineering. I've been here since 2010. Using ASPEN in 5 years already. Normally we teach students here how to use ASPEN for 3 courses: energy balance, decoration, then last one is the integrated design project. So in this video, I will show what is ASPEN, does the interface look like? Can you use it? And how does it relate to the sustainable development goal? In my case, it's SDG 9. This is contact number. My email, should you have any requests, private session, any trainings. It is. Yes. So NTW supporting 17 SDG goals, but for this course, it is related to SDG 9, which focuses on industry innovation and structure. So how does ASPEN Plus relate to SDG 9, or the simulation process with SDG 9? So in ASPEN, we can simulate the industrial design, optimize the process before we do the actual process. The innovation in industry processes by enabling advanced simulation, so ASPEN Plus can foster innovation in industry, especially chemical, energy, and pharmaceutical. In new feature in ASPEN, we can also calculate the environmental impact of the process. But for today, that's about the impact, but this is the introduction of the ASPEN simulation. So ASPEN stand for Advanced System for Process Engineering. Simulate an entire chemical process from raw material to finished product. Example of a simulation, this is a simulation environment. Here we have a resistor, the flash separator, mixer, flash separator, and the last one is the distillation column. Thank you for joining this session. There are many templates for different processes, but for my area, my field, we normally use chemical processes, under chemical processes, either specialty chemical or chemical with metric units. We can also use English unit. This is the difference between chemical, specialty chemical. The difference is noted the units. Let's, for example, here the temperature, the pressure is in bar. This one is and the report is in mole flow. This one is specialty chemical is blue. So we have two properties, not two actually. We have four properties, but today we're showing two properties. This is the simulation environment, and now we go for the first one, which is the properties one. Uh, oh, oh, wait. Oh, okay. Sorry. Thank you, Mr. Ahmad. Yeah, 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 yeah. Yeah, okay. Okay. This is the simulation environment where we do the chemical process. This is a mixer, a flash separator, and this is the distillation column. This is in simulation environment. But before we go to simulation environment, we need to introduce the component first. The component means your chemical, meaning what is the process you want to produce, starting with the raw material. There are two templates, not two templates, many templates. But for chemical processes, we normally choose chemical process. Within the chemical process, there are several, not, not several, there are two different template, either specialty chemical or chemical only, but with different unit, either metric English unit. So the difference is in unit. For example, for chemical simulation, the pressure in bar and the report in mole flow. Here the pressure is in ATM and the report in mass flow. This depends on your process. So in properties environment, show you first. Does it look like in the actual ASPEN? Thank you for joining this session. In order to get your certificate, you need to, of course, you need to register. Done already. You need to fill up the attendance form and the participant evaluation form. I already emailed you yesterday. And you need to use the name that you register in order to get the certificate from the HRD code. All right, so this is how the interface when we choose when we choose the template. So this template is quite different, I would say, because in my slide this is based on the slide is based on version 10. This is the last year version, is version 14. So the category, this is the template, specialty, chemical, refinery, mining, gas processing. Just we choose specialty. This is in English unit. You need to choose metric unit. Then just select there. Then select the. So the ASPEN Plus will direct you to the component specification. So in here, you need to find or just, let's say we want to click marker inside. Just then click enter. Or ethanol can as well. So any component you need to put it here, including the product. Including the product. Okay, let's get back to the slide. So for in the properties environment, so to navigate different environment, you see at the corner there, we have property simulation, safety analysis, energy analysis. So in property analysis, properties pane specify the component and the property model, meaning how does the component interact with each other. So we use, in this case, there are many methods, thermodynamic model, but normally we just choose non-random to liquid or an RTL. So, simulation pane to specify the process flow sheet. Safety analysis, the analyze the overall pressure scenario, analysis to do the costing. Access toolbar. For the access, for the access to toolbar. Yeah. Okay. For the access toolbar, this one is yeah, it's stuck lagi lah. Right? Software, but yeah, it's quite heavy. For the access toolbar, this is the access toolbar for V14. It's different, not that different, but they introduce some new features every time they improve the version, but not much different. Yeah. Oh, so the important one is the data source, where we do the more accurate interaction between the component. There are a few, three types of run mode: analysis, estimation, and regression mode. The difference is how the component interact to get the most accurate interaction between the component. So let's say for the estimation and regression, it is using the data from the database within the ASPEN. For the analysis, it's more toward say mm, it is using the database, but not the experimental data. Experimental data in ASPEN is coming from many papers, published papers, book, and patent. So they correlate all of the data to be used in ASPEN when they do this component interaction. Next is the next, so the run tag. So in the run tab, we have next slash run the reset together. So in the navigation pane and including the component, you can write the name. You can use the find function. The find function. The find function is similar because you can also use this compound or you can use a pumpkin. Let's say you want to find a specific chemical which you cannot find in this compound data bank. So you can use the PubChem database. Normally it's the navigation pane for this environment. Notice the half fill rate slash watts estimation. It referred to required input incomplete. So user need to specify the condition. So how to know which component was which information needed to run the simulation? We'll find this sign. But if you click next, it will revert. It will go to the particular section and asking you about the information before it can run the simulation. Okay. Database, because our expert in Unimas, it's uh, it's uh, it's a full version. Uh, It's a full version, but for study. So what ASPEN do is they give the full access. So the full access come with this database. And this is the enterprise database, the most complete database. Everything is inside it. As far as project here or the student research concerned. And so far we have all the white component. either in this ASPEN or the V14. Okay, this is how you entering the command and show you already. Should you begin? So in the find function, you can put here methanol. Find, find now. You can see a lot of method, not lot of methanol, lot of them similar to methanol. So find this is the methanol. How you know? You see the chemical section. See this 40. This is methanol. That selected compound will show you methanol. So specifying the property method. So in the property method, there are many, like a lot of property method. Here, method specification, property intensive. There's a lot of method. How to know which one? It's not easy, but there are method assistant equipped with expert how to choose the correct property method, reflecting your process. So in here, ASPEN will help you to choose the best method for your process. You must conversion chemical, electrolyte, environmental. It's a lot. So to learn more about the method in Unimas, students are learning about thermodynamic subject where the instructor teach them about the thermodynamic equation of states, okay, and how does it relate with the process. Example equation of state is the penguinism, which goes off, I think goes through who learn engineering, they normally know this. If they don't know this, they normally heard about it. Improving model accuracy. So in order to improve the model accuracy, we normally choose to estimate using a uni phase here. It's standard. So in our class, we show the student that this is the binary interaction. We show the class if we don't click this or estimate the missing binary parameters, how does the result happen? How does the interaction happen? Is it more accurate or not? Then click next. It will run the simulation. In this case, acetone NEK 1 hexene. In our case now, water ethanol, let's see. There is no error, meaning the simulation is successful or converged. So in order to improve pairwise interaction using the database, the actual database, not just estimation, we need to unselect the uniphase and click the database and retrieve the data. Case it's at the moment. This case finally picture what the nodes. So when you click retrieve data, It take time. So the interaction data, the interaction data will show here is a lot of data. Let's see. We select this one, binary VLE 110. So this data is coming from, this is the reference where they get the data. So general chemical, so chemical engineering data 1959, VLE at high pressure. So there's a lot of data. This is interaction between water and this which one that you should use is depend on your process. For isobaric, isothermal, what else? Maybe like lot. Okay. So before you select the data, let's say VL0, what is 0 is. So you run the consistency test first. So the consistency test will test everything inside the database and will show you the best, the most accurate data. So how to know the most accurate data? It's depend on the overall data quality. It's from 0 to 1. They rate it from 0 to 1. So the 1 is the best. The most accurate data is 1. But don't simply choose. You need to choose based on your system. If your system is isobaric, choose isobaric. Isothermal, isothermal if it's critical, then you choose the critical. But to choose is based on the overall data. Okay. Data regression as well. So what happened with data regression is the expert will use the data that you choose from the database and do the regression analysis with the data based on your specification. Let's see how does it uh, relate. So from here you can know statistically this data is good or not good. It's depend on the fitting. So the fitting is normally we see the outliers based on the power spray, or another one is based on the root mean square, residual root mean square. This is given when you do the regression analysis. Okay, now we go for the simulation environment. So the simulation environment, we have done the properties using the estimation manifest. There's no apparent error here or warning. For error, it's normally in red color here. If it's warning, it's in yellow. You can see that the tick, the blue tick turn to red or turn to yellow. Yes, right. Process. So this is the simulation. So for the simulation, we have a model palette. So in the model palette, there are many units. Normally, student will start with mixer when they have two, because this is a reaction. Normally, you have to input, and when it reacts, it will turn to new product with an access reactor. So mixer, so you connect the mixer with the input, you click material, and then rename the stream. So this is how it does it look like. So once it's vector, then if you want to separate with a separator from the flash tree, each have different method of I would say separate the component, and the most complicated one is the distillation. This is the distillation, starting with the STW, the ASPEN, and red frag. Each have different method to process, to operate based on different theory and model behind it. But the most accurate is the red frag. Because this is the most accurate, it requires a lot more information from the user. So this is 2 unit mixer for the incoming raw material mix. Then we separate it. This is for the sake of example. Only we don't separate it, we react it. I mean, there's a reactor. Then we separate it. So inputting the stream condition. So to input the stream condition, you need to click next or double click the stream. So in this case, the stream that we need to manipulate is 1 and 2. So stream 3, 4, and 5 is depend on stream 1 and 2. Another way to do it is to click next. So when you click next, the ASPEN will automatically goes to the incomplete section. In this case, incomplete section is stream 1 and stream 2 because of the half fill red circle. See, half fill red circle for the block, meaning V2 require an input from the user. This case 25, 1 atm. We want to mix 50 kg of water with 50 kg of ethanol. That's it. Yeah. Click next again. Require the user to input the second one. The second one is 25 and 1 atm for 100 ethanol. Next again. So The third next is for the B2. B2 means this one. Because B1 normally we don't need to input anything. It's just based on the condition set. It is to stream, but for the separation it needed before. So flash separation, this case 30 at the end, let's see. So everything turn blue now because the input is enough for ASPEN to run the simulation. So click next, run the simulation now. So it will direct you to control panel. So in the control panel, it will show you what have been simulated and if there any warning or error during the simulation. If there any warning or error, it will notify the user which block or stream that caused the error, and you can just click and go to that block the stream. So once we simulate the process, you can check the stream result either individually for the process, for the block or unit, or you can go to the result summary where it shows you the total, the overall stream from 1 to 5. How does it relate? Make sure the process is balanced, meaning 200 goes into, 200 will come out, and at the end, 200 will remain. This is the mole flow. This is the mass flow. So far, so in 4 and 5 here, where the separation happened, meaning there are no, you see here, stream number 4. Stream number 4 is up, meaning the temperature that we set inside the B2 is not enough because stream 4 is 0 now, meaning there is no separation at all just within the separator. So in this case, although it's not an error, but we need to amend it, meaning to increase the temperature. Reset, and you next. We can also click run. Goes back to the stream. All right. So now that we increase the temperature up to 100, so temperature of 100 degrees C, meaning the water will also evaporate. Yeah, the boiling point for water is 100. Yes, that one is depend on the pressure. Let's say in this case it's 100 degrees C. The higher the pressure, the lower the BTU. But for ethanol, methanol, they have lower. For methanol, it's around 79 seconds. So in this case, you see the stream 4. Yeah, it's the base reactor. Normally in here, we only have continuous reactor. For the page vector, that one is based on another 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 template. You see the string 4 is 200, but string 5 it's 0 because nothing is going to string 5. String 5 is here. Everything is evaporated inside the B2. It's yes, turn to paper or gas. Right. So we have flash separation unit. The formula. So for the flash separation unit, we have flash 1, sorry, flash 2, flash 3, each have different function. For example, flash 3 is based on vapor liquid equilibrium or VLLE. It is suitable to separate MIBK from water because MIBK, this is different component MIBK. Remember the name. It's a methyl isobutyl ketone. Second. Yeah. So methyl isobutyl ketone is immiscible in water. So they choose to use, you need to use flash 3. For flash 2 is based on the VLE, vapor liquid equilibrium. So the goal is to separate feed into two streams. So for our case, we choose to use VLE and obtain 95% water and certain purity respectively. One is different example. Okay. This is inside the flash separation. Another feature in ASPEN is can include the stream condition. So to include the stream condition, go to the flash. To add the stream condition, click on the temperature. This is under modify. Modify tab on the quick access toolbar. We have temperature, pressure, vapor fraction, mass flow rate, volume flow rate. So in this case, we just choose 2, temperature and pressure. See? You can also put mass flow rate. This depend on your requirement, user requirement. Distillation column. So for the distillation column, there are 3 types of distillation column. Each have different method to calculate the distillate or light key or heavy key. The most user friendly, but it's not that accurate, is the ISTL. So normally when we do distillation simulation, we start with the ISTL first. So for the ISTL, we see, okay, this component can be let's say separated. It's not an isotropic nature. Then we go to the STW to make it more detailed. Then the last part is then we use the frac to do uh, the small detail like how many, sorry, the number of stages is for all the type of column, but how does the column look like? The way, uh, how high is the way? What type of blade inside the column for the stages? That's all can be specified only in rectified column. see it. So in this case, we need to change this to 5 again, so that it turns to water. Then connect the distillation tower, distillation column. Uh, Kalau komputer tak berapa laju, like mine is quite good. It's 40 gig RAM still. That's smooth. And normally we use a computer in our lab. One is it's better spec than my computer. So this is how the uh, distillation will be. You click next. It will ask you about the specification inside the distill column. So we don't know what is the stages. So how to start? Normally we just do the trial and error unless you have the manufacturer spec. Then you can use that spec from the manufacturer to do the simulation. The F10 issue is 0.5 first. So effect ratio means how much will return back to the distillation column, how much will go as a product. This is happen at the top of the column, at the condenser there. So here, sorry, here. Condenser type is the term. Distillate to feed ratio. The thing is ready. Reset and run. So in control panel, simulation for 3 block, B1, B2, B3, B4. No errors. So goes to the result summary stream. Let's see the six, stream 6 and stream 7. So for stream 6 and stream 7, stream 6 is at the top. Top is stream 6, bottom is stream 7. So 116 flow for the top, 82 for the bottom. So this is the component. This is based on mass flow rate, kg per hour. We can also see the fraction of it, the mass fraction. So in this case, most of the component is methanol, then ethanol and some water. And most of the water is at the bottom. Let's see, make sure it's balanced 200 in, 200 out. Alright. So this is the complete system. From mixer to flash, then goes to the mixer again. So from the mixer, some will go to the mixer 2, mixer 3. So there's a line here goes to the mixer, then we have from IBK2 react with the unreacted H2O acetone in this case. Goes to the mixer, goes to the flash, then goes to the mixer before it's separated in the distillation column. Oh, this is using the STW. All right. Let me show you the STW as well. So for the STW, uh, it will require you to input the stages as well. But in this case, you see, it's more specific, asking about the light key component, the heavy key component. So recovery of light fluid in distillate. More light, more light, more light key in distillate over more light key in filter. 2.5, 2.5. Set. Okay. Now we have warning. See here? Error is minimum refractory ratio created from underwood equation is negative 0.317 and 7. So refractory ratio reset to 0.1. So this is the error. If we go to the main flow sheet, there are that sign, meaning error inside B6. Minimum ratio. So we need to do something with the refractory ratio. These number stages normally can say improve the system, but too much number of stages, although it's good, but with a cost, will added cost to the capital because it's higher and what many stages etc. It's, and it still added, but it's still minimum ratio is something we need to do. Another 5 minutes. Okay. So only when we do the simulation, we run it not blindly like this. Because this is just an example. We normally have the data sheet So not the data sheet, the data from the manufacturer or the destination column that you want to use. So based on that data, we can input inside this simulation. Uh, and from there, we optimize it. We do the analysis. We have sensitivity analysis inside ASPEN as well, in which the ASPEN can simulate within a set of data, range of data, we do a simulation and see how does it relate the, with the product. If normally it's a product. Let's see if there any question. Let me share with you in this platform. The yes, check my email. So for the attendant, you can use this form and participant feedback. They have two forms you need to fill up. Attendant and the participation feedback form. I get your presentation. Sure. Can run batch. Yes, only in kg. I don't understand, but you can use any unit, but normally it's either kg per hour or 1 hour. Oh, sorry. I emailed yesterday. You don't have question to view expert respond. Which form is it in? Is it both? Oh, okay. They asked me to create this link. They didn't teach us how to create the link so that student can access it. How about the output assessment? Sorry, the participant feedback form. You can access like on Microsoft Form or like. You can ask questions. So, yeah, so yeah, it's 9 a.m. Is it possible to Let respond. Okay. One can respond. Copy the link. Shorten the link. Copy the link. Now, how about this one? For the recording, uh, I will put it in YouTube, but I need to cut this one. Only the training part. All right. So hopefully you can access the form now. They didn't mention that need to select anyone can respond. So hopefully you learn something, uh, and this is a very short one just to introduce. But in Unimas, normally the student will learn about how to simulate all of this anti-reactor. If the time permit, I will show them the dynamic, ASPEN dynamic, meaning you can set point and see how does the system react until it get to the set point. Then we also simulate the pump, the piping, the valve. Later on, they will use it in their integrated design project. Anything that we can. Okay, so I think that's all from me. Hopefully, we can make again later. Let me share with you some of the video. Yeah, I will show you the recording. I will upload the recording later. Yeah, this weekend. All right. So if there is anything else, we should conclude the work. Sorry for taking your time. It's 1 second. I have another one in another session, 4 p.m. today to 5 p.m. That one is we learn about uh, soft in Excel, in which we design a bar rack in wastewater system. There are say primary, secondary, tertiary treatment. So bar rack is the primary. So how we design the bar rack using an Excel. Uh, it's interesting.